work and brain imaging. So I will give the mic to Matthias Berger, who will introduce the Wim Hof method to you. Thank you so far. So my name is Matthias, as you heard. Just information for tomorrow, who is interested, maybe we have at 11:30 a.m. a workshop about the Wim Hof method. We have a third instructor here, he's sitting here in front from the Netherlands. And if you want to know more, you can also ask tomorrow at 11:30. We make a nice dive in the creek there. It's 8 degrees Celsius now, so that's a little bit cold. So about Wim Hof. Houston, we have a problem. There it is. This is Wim Hof. Maybe some of you guys know him. He's called the Iceman, yeah. Dutch guys are very nice, yeah. He made a lot of crazy stuff. For example, I will translate some things from here. The longest ice bath, it was 1 hour and 52 minutes. So that's really long. Marathons in Finland, minus 20 degrees Celsius. He hiked the Mount Everest only in shorts. This is really crazy, but it is possible with the Wim Hof method. So you're able to control your body. It has a lot to do with mindset. And the interesting thing is, here it is, marathon in the desert of Namib without water. So the interesting thing is the Wim Hof method is also helps to work to deal with hot environment, not only with cold. So let's have a short look at the 3 pillars of the Wim Hof method. It's very short overview. So the questions afterwards, please.
Shoes? Did he have shoes? Or just
On the Mount Everest, he had shoes. Yeah, it's for the feet. It's very dangerous.
No shoes. He had no shoes.
He had no.
Instead of Mount Everest.
Only on Mount Everest. Yeah, on the marathons he did it without shoes, but in the mountain environment it's very dangerous because of the grip. So it's very icy and it's not healthy then to slip away. Okay, we have 3 pillars of the Wim Hof method. One is the cold therapy. How does it work? So we live in a very warm environment. We have heated houses, heated cars, and so if we are outside, we wear jackets. If we see goosebumps, oh my God, I have to wear a jacket, otherwise I have to get a cold. What we do is, we do the opposite. We go in the cold water to make training for the cardiovascular system. So we go in the cold to avoid getting a cold. That's important to know. It's also a little bit of, we play with sympathicus and parasympathicus, so with gas pedal and brake of the body. Very interesting to reduce the stress and have a better mind. Yeah? The breathing exercises, it's for sure for you here the most interesting part. What we do with the breathing exercises, we change the pH level in the body, and also the feeling of pain is less after the breathing exercises. We come also in the perfect state of commitment because the head is then empty after the breathing exercises, and that's the third part. To do this stuff in the environment, in the cold water, you have to be committed, you have to be focused. If you're not focused in the cold water, you can do it maybe 30 seconds, 1 minute, but not half an hour or like Wim, 1 hour and 52 minutes. So that was very long, yes. It was a short overview. So in case you want to learn more, tomorrow 11:30 you will find us, and I give now the microphone to Matthias again. Matthias to Matthias. Thank you so much.
All right, okay. Now we're heading towards science a little bit. So there has been some publication done with Wim Hof himself and with his method. So he was getting to know some scientists, especially in the Netherlands, and they were trying to figure out what happens during the cold exercises, what happens during the breathing exercises, what effects they could measure them. And they tried to use methods and techniques from immunology that they are very experienced in. So they have a well-established method, and this is to inject endotoxins. These are dead bacteria into people that are evoking a very harsh flu response, flu symptoms, so headaches, and what you know about what you experience yourself when you get a flu. And these are an injection. This is not dangerous for the body. So the body thinks in the first hours this is something dangerous. They are parts of the bacteria that's called LPS, lipopolysaccharides. Some researchers call them also little pieces of shit, because they are parts of the cell membrane of bacteria, and these are evoking the immunological responses. So they were injecting him and published a paper 2012 where they just investigated Wim Hof. So, and they found amazingly very interesting results. And they thought maybe this is very special man. Yeah, it's not transferable to the overall human beings. So they tried to set up another experience that has been published 2 years later, where Wim Hof has trained a group of people with his method. And this group were also injected with the endotoxins, and they were compared to another control group that haven't been trained with Wim Hof. So, and they tried to figure out what's going on in the blood and what parameters are very interesting. So Wim Hof has trained this group for, I think, just 6 days in Poland, very intensely, and they trained for themselves at home in the Netherlands for 4 days additionally, before they went into the medical experiment. And I will show you some parts of the publication to just highlight what's very interesting there. As you can see, these gray circles are depicting the breathing sessions. So at 0, they got the endotoxins, and they started 1 hour before the injection with breathing. And the breathing session lasted for about 3 hours. So all the way during the coping with the injection, they did the breathing technique. And as you can see, the pH level with the trained group in the right corner goes up compared to the control group. They were more alkaline. And you can see the oxygen saturation in the blood was going down. I can show you another slide later. It's more detailed there. And you see also here in the lower left side that the symptom score, so what the people subjectively experience during these injections, so the symptoms of nausea or headaches, were much lower in the trained group. They had, some people hadn't any symptoms at all. Some people had very few symptoms compared to the control group. And here you can see one example from one person. So they investigated 12 people in the trained group and 12 people in the control group. And this is one example from a guy from the trained group. And you can see Wim Hof breathing consists of 30 breaths deeply in and just letting go. Then holding your breath without air in your lungs for as long as you can do. Then breathing in, holding for 10 seconds, and then letting go. And this is 1 round. So you can see this is called in this publication hyperventilation, the breathing rounds. So you can see hyperventilation here, respiratory rate, then the next column is retention, hyperventilation, retention, and so on. And you can see very interestingly that the O2, the oxygen saturation, lowers a little bit each round and goes to about 50%, which is very low. And we tried this also with monitoring the breath retention phases at our medical school. And we had 50%, we had 40% people, and they were completely fine with this. So this is very, very interesting. And what is very astonishing also, they didn't look only at the blood gases or the O2 saturation, CO2 saturation. They looked also at the hormones in the blood. So what you can see, and it seems to be that the Wim Hof method is eliciting a kind of controlled stress response. So when the autonomic nervous system, more specifically the parasympathetic nervous system, the stress system, the fight and flight response system, is activated, you have normally a kind of external trigger. Yeah, you seem to be in danger, or you seem to judge a situation as dangerous for you, so you get a stress response. And the breathing technique seems to evoke a stress response, which is corresponding to these hormones here, that is controlled, because the main hormone for the sympathetic nervous system is norepinephrine or noradrenaline, which is the same. This is not very different between the groups. It's just different on the last hours when the breathing session is already finished and terminated. So what's really interesting is that the adrenaline or epinephrine is much higher during the breathing, and it's even higher before they get the endotoxin. So before the 0 time point, 1 hour before that, when they started to do the breathing, the adrenaline is very high. So, and the researchers concluded, based on these results, that the adrenaline, which is already known, is triggering immune responses in a good way. So if you have to fight and flight, you can't cope with any diseases at this moment, or with any things that might disturb you from fleeing or fighting. So adrenaline is emitted, and this is a good thing for coping with diseases and with your immune system. Dopamine seems to be not very different during the first hours, and cortisol also, the stress hormone, which is eliciting or which is emitted in the adrenal cortex, compared to adrenaline, which is emitted in the adrenal medulla, is not very different. It's just different in the last hours when it's faster down again. Do I have time? Hopefully, yes. The last slide from this publication is exactly with these cytokines. These are little proteins that are triggering and mirroring the immune response. And you can see here in the first A, B, C, D, E, F slides that compared to the control group, the specific immune responses, tumor necrosis factor alpha, interleukin 6 and 8, which are pro-inflammatory, so triggering your immune response, is much lower in the train group. This is here the train group compared to the control group, whereas the anti-inflammatory responses reflected in the interleukin 10 is much higher in the train group. And this is, I think they wrote it like 200% higher than normal. So they can trigger their anti-inflammatory responses with this breathing technique. A thing which Wim is very proud of is that he has been already mentioned in one chapter in a biology book in the United States, Biology Now. And the method and the results are explained there. And what is also very amazing is that one of the high-ranking journals in science at all, like this one, Nature, has a little article about the publication about Wim Hof and the results that has been found there. So, I will give the mic to my wife Dina, and she will tell you more about what we can do with brain imaging on what functional MRI is. So, the stage is yours.
Hi everybody, thank you for the warm welcome. I think this is the first talk about science that I have ever done without shoes. So, yes, functional imaging. I'm very happy that you're all here and that you're not scared by this terminology. And there is really no reason to be, and I'm going to hopefully give you a little food for thought and some things to put into your pockets to explain to your clients and other people who might be asking you about these things. So functional imaging, what is this? We have a big magnet. It's the MR machine where we put our subjects in and we measure their heads. And then we get some pictures. And you probably have seen something like this, right? Where you get these little colorful blobs on an image of a brain. So there are two different things that we measure. Some of you might have been in an MRI machine because they had some issue with their back or some nerve issue or whatever. And this is usually an MRI, which is done for brain anatomy or anatomy in general. So what we do essentially is we have a very high resolution image of the brain. It's like a photograph. Just the status quo, one image where you can look at pathology, maybe is there a stroke, is there a herniation of a disc, something like that. But what we're doing is we're looking at brain functions. So we're looking at the brain working. It's like a video of the brain. So it's not one static image, it's several images over a time course. That's one important distinction. And I'm going to show you, I hope this works. I'm going to show you two videos of the kind of data that we get out of the MRI machine, and who the person who spots the colorful blobs will get a reward. So I hope you can see that there is something moving here. Now there is breathing, and now there is no breathing. This is the retention phase. And were you able to see the differences? Yes? Yes. And I have another video where it's even clearer. It's the power breathing. This is you inhale, exhale very fast, and then you inhale and press. So you have a breath retention with pressure, with air in your lungs. This is a little more forceful. And it starts now. You can see really a lot of, it's like disco lights. And now it's gone. This is the retention phase. So has anybody spotted these? No. Sorry, no prize for you. But what are these colorful blobs that we see? It's not in the raw data. So what is it? It is, in essence, a graphical display of statistical comparisons. So we do have to do some calculations afterwards, and what you see here is just statistics in colors. This is all there is to these blobs. So it's not something that is in the brain, really. It's something that we, in the post-production, so to say, map onto the brain, but it's statistics. Okay, so but what do we measure in functional imaging? And what we measure in functional magnetic resonance imaging, which is long for fMRI, is we measure the vascular response during brain activation. So we don't measure neural activity. This is also another important thing that you have to keep in mind. We measure changes in blood flow that we know are somehow connected to neural activity. So imagine you have a neuron that is active, and in order to be active, it needs metabolism. It needs oxygen. So there is a difference in oxygen utilization depending on whether a given neuronal population is activated or not. That's one thing that constitutes the bold contrast. The other thing is blood flow, and the blood flow can be influenced by, for example, hypoxia, hypercapnia, other things. And the third part that is important for functional imaging is blood volume. And blood volume is influenced by vasodilatation, so autoregulation of the vascular response. So actually what we're measuring is changes in blood flow and blood oxygenation. More activity, more oxygen consumption, more blood flow to the region. And the good thing about this is that the magnetic properties change when oxygen is consumed, and we can measure this contrast. And this contrast gives us the statistics we need to create these colorful blobs. Okay, so it's a little through the back door, actually, what we're measuring. The bold contrasts, just so this is the take-home message, has something to do with oxygen consumption, which has something to do with neural activity. Okay, so you're breath workers. You know that breathing has profound effects on your physiology right away while you're doing it. And the good effects that you would like to measure in the brain are actually really hard to measure, because imagine you're doing this, you're breathing really a lot of oxygen in, you're exhaling a lot, so the O2, CO2 levels change quite a bit. And you were able to see that actually with the little movies. You saw that there was a lot going on in the whole brain. And this global effect that you see during the breathing makes it really hard for us to get these blobs, because then they are very unspecific, right? Because what we would like to have is something like this, small regions that are responsible for controlling your breath or whatever you're doing. But actually what's happening is that the whole brain lights up like a Christmas tree, okay? So this is probably one reason why breath work has not been very prominent in neuroimaging, is because it's technically really hard to do. But there have been some people trying it, especially in animal models, which is not something I think is a good thing, but some of the things we know are taken from animal research. These are studies in humans, and this one is actually a CO2 challenge. So people didn't do anything specific with their breath, but they were, through a mouthpiece, they received air that was changed compared to the air you normally breathe. It had a different CO2 level. And then the body, of course, notices that, even if you're not consciously aware of it, and tries to counter-regulate this effect. And we only found, well, actually 2 days ago I found another one, but this was the one study that we found that actually did something you might consider in the direction of breath work. They told their subjects to hold their breath for 15 seconds. So you breathe normally, and after the exhalation, you hold your breath for 15 seconds. And then we don't have this Christmas tree problem, right? Because you're holding your breath. And I don't want to bore you with the gory details of the brain regions. I just want to show you that they do get some results. And they did some correction for this O2, CO2 problem that I've been explaining. But it's very hard to tell whether these are real activations or whether they are more related to the overall change of oxygenation in the brain. This is only one study, and usually you need replications and replications and replications of something like this to be confident that this is a true effect, which is why I will not give you a breath holding is in that area take-home message, because it's just not there yet. So these are in cortical and subcortical areas. So that's the cortical areas are the ones that have something to do with conscious, controlled, effortful activity, and subcortical areas are more related to emotional, more automatic responses. And then if we go one level below to the brainstem, they also looked at the brainstem, and I will just leave you with the images. So they did something there, but bear in mind, this area, this is the brainstem, it's down here. It's part of the brain, and it's actually, it goes into your throat a little bit, right? And what goes through your throat are all the large vessels going to the brain. And what do? They pulse. What does every neuroimager hate? Movement. Because movement, especially if it's correlated with your task, will make it really hard to see if there is anything there. So I don't really trust these results, right? Because these are from 2008 and 2009, and there was just no, the methodology was even less well adapted to what we need. So they did find something there, but it might as well just be pulsation from the big vessels. We don't know. This is taken from animal research, but this is something that you can really take home. This is the brainstem, only the brainstem respiratory network. And you can see that there are a lot of nuclei. It's very complex. Something so simple as breathing is so complex in the brain. And this might give you a clue why breathwork has so many effects. Like put a cortex on top of that, of a higher mammal like human, and multiply that by, I don't know, I don't want to give you a number, 1,000, and it gets even more complex. So the effects that we're looking at are unspecific in the sense that they are very much diverted in a network, and there are several routes to go to try and tackle this topic, and neuroimaging is one very interesting but also very complex part to do this. Nevertheless, we're scientists, we're nosy, and we would like to do things that, or measure things that nobody has measured before. Star Trek. Yes, I watched it. So we are setting out to do some research with the Wim Hof method, and the good thing about this is it's very specific. You have a very specific breathing method that you can measure. There has already been stuff published on this, so we have some knowledge about where to look, like what might be a good idea to look at. And so we're going to have 2 branches, and this is work in progress. We're just setting this up. We're going to put people into the scanner. We're going to look at O2, CO2 saturation, and because we need that to correct our imaging data. And one very new development that is going to be very helpful for us is that we have a colleague in Hanover who is a brainstem expert, and he has developed a toolbox that makes it possible to mask the brainstem and to filter out all this pulsation and everything, and make all the nuclei visible. Also, the measuring sequences that we use now are very high resolution. So they used to be 3 by 3 by 3 millimeters, and now we can go down to 0.7 millimeters squares. So that's a lot more fine-grained than it used to be. And I'm very keen to see what we get from these methods, because this has never been done before. The other branch will be HRV analysis and some blood work and blood gas analysis. And for both branches, we're going to do functional medicine, which is essentially looking at the microbiome, looking at inflammatory responses and the like. And this is also a very new development, and I think there are going to be very interesting results in this, just from breathing. I mean, I don't have to tell you, but okay. So as Matthias has already said, there will be a workshop tomorrow at 11:30.
I heard it on 11:30.
11:30?
Yeah.
Okay, so 11:30. And you can try, because the guys from the Netherlands who did the PNAS study with the group are now setting out to investigate the cold immersion, the effects of the cold immersion, which is one of the important pillars of the Wim Hof method. And I believe that this is also very important, especially for the effects on the immune system that we see. So they really go hand in hand. And if you're interested, try it. It's really amazing, doing the breath work and then going into the cold water. I mean, some of you have some experience with this, but it's really amazing. And I'm not sure if the next slide is correct. Time for questions? Do I have time? Do we have time for questions?
Yes. Yeah, of course.
Yes, okay.
Yeah.
So I hope I didn't confuse you too much, and I hope that you got some food for thought and some things to put into your pocket and know what these blobs mean and how to interpret them. And when people come with, well, look, there's a study here, then you can say, well, be a little careful. We don't know that much yet. We know it works for us, but science has to catch up and give us some time, and we're at it, and we will hopefully at one of the next GEEKs be able to present the results.
Thank you very much. Can we have the three of you on the stage, maybe? Yeah.
Yeah. Thank you.
And I'm seeing a lot of lighted up Christmas trees here. That makes me very happy. Yeah, at least the door is open. Who is having a question? Who wants to come up with a question? Do we have a third microphone? So we're going to collect questions. Maybe we start at that.
Test.
Yes.
Maybe we start at the left side of the room and collect 3 questions. Maria. Yeah.
Hi. Thank you for this perfect speech. My question is, these boot camp participants in Poland, did they only do breath work, or did they do all 3 columns of the Wim Hof exercises?
You mean from the colibacterial experience, or you mean in general?
What Matthias demonstrated. And you said 9 days in the boot camp and then 4 days at home.
Yeah, they did the whole program.
The whole program.
Yeah.
I wasn't quite clear about the difference between the study group and the control group. That the study group did the training, but did both groups do the Wim Hof breathing, even the ones who hadn't been trained?
No. The control group did actually nothing. They just were injected with the endotoxin. This might be a kind of criticism, because usually you try to balance the group, so they should have done something like meditation or something at least. Yeah, but they did nothing. Next question.
Okay. I'm interested, you said that the breathing technique is also about sympathicus and parasympathicus, and so I guess that with the Wim Hof breathing technique, mainly the sympathicus will be active. So I'm interested in what does Wim Hof after his cold water breathing to relax, and that the parasympathicus gets active.
drinking beer.
Maybe
I know it's more like when you're clenching your muscles, it's like an activation. But if you then afterwards release, it's a relaxation. So it's similar to how it's called autogenous training in English. Autogenic training or progressive muscle relaxation. If you clench and then let go, it's like relaxing and doing something for your parasympathicus also. So it's similar, very similar to this.
And the parasympathicus is very sensitive to thermoregulation. So the cold water, when you do it in the right way, is having a very, very strong effect on your parasympathicus.
Next question, yeah.
Okay.
Finally.
I'm super excited, so I'm already thinking about the far long-term implications of really being able to use cold breathing, etc., to help people with a variety of conditions. So I'm wondering, my question is about the funding for studies like this, because obviously those future implications aren't terribly exciting to the pharmaceutical industry, to a lot of professions who are treating people with these conditions in a very different way currently. So I'd appreciate both your views on the funding, also for this study, how it's being funded, and has it been difficult, and your general reflections on that topic.
Okay, yeah. I think there's no problem in general to get funding. So we're trying to make some applications to get funding, because the usual ways to get funding in Germany is not specific to any pharmacological companies. So it's more from the Deutsche Forschungsgemeinschaft. This is the one you get most money of, or Volkswagen Foundation. Maybe not this time. Yeah, you know what I mean?
They have to with fresh air.
Exactly. Yeah, that's the problem with fresh air, right. Yeah, so we're optimistic to get some money from this, but we are actually aware that pharmaceutical companies are not that keen to support these kind of research. Yeah.
Yes, I think the good thing about academia is that we are, at least for this kind of research, not so much dependent on big pharmaceutical companies. But then, the other thing that is important, I think, is how does that translate? Because you get funding, you do a study, and then what? Because if the big pharmaceutical companies are not boosting your work and not trying to sell it to people, then how is this going to get out there? And this is where something like the podcast comes in, where you broadcast this to a larger audience without having a relay station that you have to go through, and you can just interview people and just make this knowledge available. And this is why we try, and I would really appreciate your feedback on how we've been doing, trying to express what we did and what we found to as many people as possible in an intelligible way, not just for scientists, but for everybody. And this is, I think, what needs to happen more in science, and this is why we're doing something like the podcast or speaking at conferences with people from other disciplines, and this is really important to us because this is the way this knowledge is going to get out there.
Yes, the third panel was the focus. If you don't have a focus, nothing will function, neither your cold therapy nor your breathing exercises. Now, focus is not specific for Wim Hof's method. For example, when you go to a fire walk, if you don't focus, your feet get burned. So it doesn't work. And what do you have to say about that? So, what is the impact or the importance of focusing in that method for success in that method?
completely agree. I just try to think in scientific terms, and it's very complicated and difficult to investigate focusing during breathing or cold exercise in the MRI. So cold exercises in the MRI is very hard to do. Wim Hof is right now collaborating with researchers from the University of Michigan in Detroit, I think. They have a swimsuit where they can cool down your body temperature and put you in the scanner, and he was already inside the scanner and did some research. I'm curious what they found out, but focusing is something very hard to define, you know. There have been studies about consciousness, about focusing for a specific task. That's what I've been done for many years. It's called cognitive control. But we're trying to combine things. So, but this will be research that will be done in later years. We will start with this kind of presentation right now.
Can you actually explain a little bit about that, what Wim told me?
You can sure, yeah.
Well, about the investigation that you just told about in Michigan, Wim told me about the results of that study, and I'll just get up here for a second. But Wim told me that they did the investigation with the NASA suit with cooling down his skin temperature and his body temperature while they measured his brain activity. And he said that for the first 2 days, it was really difficult for him to maintain his focus, and they couldn't really see any differences. But on the third day, when he said, oh, it really has to happen now, this is my last chance for this really expensive investigation to really show what I can do, he got into his focus and he used his mind so strong that they measured all this brain activity, and at the same time, his skin temperature did not go down at all. So there you can see that the mental and the mind aspect of this whole technique is super important. So with his mind, he could control his skin temperature.
Yeah. Right. Let me just one second. So he explained this to me also. So scientists are always very hesitated because it's a live stream and this is not publicated data, so you know, published data. So yeah, you can come up on the stage and I will be killed afterwards. But if you are really curious about this, Wim told me also what he has experienced, and I've done an interview with Wim Hof on my podcast. It's in English, and it's on the website inside-brains.com. Please write it down or ask me. It's easy to find, and it's for free. You don't have to pay anything. You can listen to this interview and maybe learn something about this. Inside-brains.com.
Yes, I think your question also hinted at the fact that this is not very specific for the Wim Hof method, and this is true. But I think there is not just one way to roam, right? So there are all these different techniques who have some things in common and some things that are different. And I think one exciting path for science is coming from the outside, trying to find what are the common denominators. So what is important for all these methods that have effects, and what is the common thing? So focus for sure is one thing, and I think doing the cold exposure really forces you to focus a lot and very instantaneously. And I think this is one thing that we would like to do as scientists, is trying to find out what is it that creates these amazing effects that so many techniques have.
Yes, okay, that's a very good answer, but when you convince your clients to use breathwork or this kind of thing, then you also have to convince them to focusing.
Yes.
That means you have to learn or to instruct them how to focus, besides how to breathe, you know.
Yes, and I think that it gets easier with the more you do it. As you said, it's very unspecific. It's not really easy to say what do you have to do exactly to focus. And doing the breathing and doing the cold exercises will teach you very quickly what that means. I think that's one of the things why the Wim Hof method works so quickly.
Yeah, and it's very interesting to see with children. My son is here, Philip, and he's doing the Wim Hof method also because he's copying me with the breathing technique, and he's going into the cold water as well and trying to stand the cold, and he's doing a great job with this. So it's a lot about just looking at some people who are doing this and try to copy this and experience this for yourself. Like Wim Hof always saying, feeling is believing. So if you just try to do it, you see what is really in the method and what you have to do.
Okay, we have time for one more question. So if you feel like you want to address the burning issue that is...
Wolfgang, bitte kannst du übersetzen für mich. Mich würde interessieren, ob es Bilder gibt über Dissoziation im Gehirn, also Gehirnbilder, im Zustand der Dissoziation, beziehungsweise auch der Panik.
Are there images of fragmentation and dissociation, which can you identify that with your method?
Und eventuell auch dann ein Zusammenhang eben mit der Funktionsweise des Sympathikus- und Parasympathikus-Systems, ja, in diesen Zuständen, ja, und was Atemarbeit sozusagen dahingehend auch bei psychiatrischen Patienten bewirken kann.
And can you relate that to states of the autonomous nervous system? And the next step, how you can work with these phenomena in a psychiatric
I can give you a short answer. I don't know, because this is not my field of research, dissociation. I don't know if there are any studies. Maybe there are, but I don't know. You know?
I know the practice at our medical school is that if people dissociate, like they had one person who dissociated while they were lying in the scanner, and usually what they do is you don't know really when it happens, and in order to be able to have the statistics, we need to know when what happens. But with panic disorder, it's really hard. I don't think it has been done because it's you have to lie down, you get this thing on your head, you're in that round thing, and it's incredibly loud. It's like a jumbo jet starting beside your ear, so you have hearing protection. I think if you are having a panic attack, you're not gonna go stay in there. So this is, I think, really hard to do. And with dissociation, it's because it's so unpredictable, it's not easy to measure. Because you have to know when which event happened. And I don't think there is really any research on this. It would be, maybe there is, but I would imagine it's really hard to do.
Okay, so thank you very much. Thank you. Coming and enjoy your dinner.
You want to do a question? Or I want? Yeah.